So now that you've got checked and unchecked exceptions down, or at least an understanding of them, what do you do when you have multiple exceptions that can be thrown? Well, there's a couple different ways that we can handle this situation. So let's take a look. If several statements within a try block can possibly throw an exception, and the exceptions are of different types, what can you do? Well, you can either A, use a generic catch block that handles every type of exception that might be thrown, or B, you can provide a sequence of specific catch blocks with each catch block handling a different exception type or group of exception types. And we're going to walk through some of these examples, of course, so don't worry if it doesn't make sense. You'll understand in a few minutes. Here's how we go about providing a generic catch block. And it's actually pretty easy. All we really need to do is define a catch block with an exception parameter E. Now, optionally, you can use the exception parameter E to access some useful data. We can use the .getClassGetName method to return the name of the class that threw the error. Additionally, we can use the getMessage method, which gives us a description of the thrown exception. And this is some of the information that comes up if your program crashes and you see it, in the output. This is some of the information that you're going to be able to handle inside of your program instead of waiting until after it crashes. In a catch block heading, if you use an exception parameter, then all thrown exceptions will match up with the exception parameter. So why is this? Well, a thrown exception will be caught by a catch block if the thrown exceptions class equals the catches heading parameters class, or the thrown exception class is a subclass of the catch headings parameter class. Whew, that's a lot. Well, since every thrown exceptions class is a subclass of the exception class, right, all thrown exceptions will match up with the generic exception parameter. So basically, everything that I just said is, remember, these right here are unchecked exceptions, right? And these are checked exceptions. So everything is derived from this exception class, and part of polymorphism in object-oriented programming is that anything that is a derivative of exception, so anything that's a child class or a subclass of exception, can be used where the exception class is used. So if we are having a catch block and the parameter is an exception class, then anything that's derived from the exception class will work there as well. So that's, hopefully you understand that. Okay, so here we have our read from file class. And basically what we're going to do is we're going to ask the user for a file name and then attempt to read in the contents of the file. And as you can see here, the scanner class has the option to or can possibly throw a checked exception. And since we're initializing file in here, we have to be able to handle that checked exception. Additionally, paths.get can throw an invalid path exception, which is a unchecked exception, right? So we don't have to catch it, but if we don't, then the program's going to crash. Additionally, file.in has next throws an illegal state exception, which means if file in was closed, because we can close scanner objects to free up system resources, if it was closed and we call this, then it's going to throw this illegal state exception. And finally, line in or file in.next line throws an illegal state exception because file in could be closed, and a no such element exception, which is an unchecked exception. Now here we're never going to run into this situation because we're handling the code carefully, right? We're checking to see if it has next. So if it doesn't have a next line, this is never going to throw an error for the no such element exception, because it'll never be the case that we get to that point, because we'll just skip this block if there isn't one there, right? So we've handled this exception through careful programming, right? The illegal state exception we're not overly concerned with because we're not closing any of our scanner objects within this code. So finally, we get down to the catch block, and you can see we have the generic exception E. And here, notice we print out the class and the message. So if we run this program, let's compile it and run it and enter file name. And if I say, okay, let's pull up bob.txt. Okay. It says class file no such file exception, bob.txt, right? So those are our two messages, right? So the first one, if we come down here, is get class. So this class is the exception that was thrown for the, for the E, which is our exception, and then the message was bob.txt. All right. So now let's run a file that does exist. So we got this Einstein right here. So let's run Einstein, right? All right, so we're going to run the program, and we're going to type in einstein.txt. So as you can see, it did what it was supposed to do. It opened up the file, right? And then while it has next, it printed out the line. If I open up the actual text file using TextPad, right, or Notepad, you can see here this is the contents of the file, and the program read the contents of the file and printed it out. So that worked, and we didn't have to worry about there not being an end of line because it always ran it. When a try block might throw more than one type of exception, instead of providing one generic catch block, you can provide a sequence of catch blocks with each catch block handling a different exception type or group of exception types. For example, here you can see we're catching the invalid path exception and the no such file exception with this block right here, and then all others we're catching down here. All right. Notice the pipe operator. This is normally a bitwise OR operator, but in this case it's simply a syntax rule that was added in Java 7 to make life easier to specify multiple exception classes. And in this case, this block will handle exception class A or exception class B, but not both. Before Java 7, you'd have to have a separate catch block for each exception type. So the question is then, what do we gain by using multiple catch blocks rather than a single generic catch block? It obviously adds more code complexity to our project, right? Well, the benefit is that we can handle each exception differently and make our code more robust and fault tolerant, which is something you'd want to do for any non-trivial project. If multiple catch blocks are used, the first catch block that matches the type of the exception thrown is the one that is executed. The other catch blocks are then skipped. So here, this may throw type exception C, right? And this doesn't catch exception C, and this one doesn't catch exception type C, but this one does. And so we're going to iterate through them until we get to the one that actually catches it. For example, let's take a look at the read from file 2 program as an example. Here you can see that we have our catch blocks, right? And we can put the generic exception block at the bottom because the exception class is the superclass of invalid path exception and no such file exception here, right? So you want to go from most specific down to most general and handle all the different exception classes in that way. And we're not going to bother running it because it's the same thing that we did before. We're just handling the exceptions differently. And here's just another way to look at it. You need to handle specific exceptions like invalid path and index out of bounds before you catch their generic superclasses of IO exception and runtime exception, respectively. Remember, though, that exceptions derived from the runtime exception is optional, so you don't have to catch it, but you should handle it, either through careful coding or the try-catch blocks, right? So runtime exception is optional, IO exception, these are mandatory. All right, so this is just one more way to look at it. Hopefully it should be sinking in by now. But anything that is derived from error or runtime exception is optional. It is an unchecked exception, which means you can handle it with try catches or with better coding, right? Anything that's not derived from those things is a checked exception, and you must handle it with a try-catch block. And of course, your compiler will tell you when you go to compile and you get an error. So, as you well know by now, if your code involves a checked exception being thrown, you must include a try-catch mechanism, right? Remember, any exception not derived from error or runtime exception is checked. Without the try-catch mechanism, your program won't compile successfully. On the other hand, if your code involves an unchecked exception being thrown, it's optional to whether you include a try-catch mechanism for that code. All right, so hopefully this has been beaten into you well enough. Without it, your program will compile successfully, but an exception is thrown, your program will crash. If a crash occurs, the JVM prints a runtime error message that describes the thrown exception. So let's take a look at an example of this, although I'm sure you've seen it already. Let's take a look at the number list class and see at some of the errors that we can generate. Here we have no error correction. We just have while this doesn't equal Q, do this thing. Okay, we have an array that stores 100 items. So there's off the bat, there's a couple things that I can think of that are going to go wrong. So let's go ahead and run this program and try some of them. All right, first of all, we can enter a non-number, right? And as expected, we get a number format exception. That is the exception that was thrown. This right here, all the @Java, that's called the exception or the call stack. And so you can see the order in which things were called. All right, let's try some other ones. What happens if we hit Q right away? Look at that. We get an arithmetic exception, divide by 0. We all know you can't divide by 0. It's undefined. All right, so Java doesn't like that either. What if we enter more than 100 numbers? If we look at our array, we can only store up to 100 things, right? So let's enter 100 numbers. And I'm going to cheat. I'm going to paste it in. So you can see I just pasted in 1 to 101. And then the program's going to keep asking you to enter a whole number, and then it's getting it from the buffer. So we look at that. Exception in thread main Java index out of bounds exception. So there you can see 3 different errors in one program that are obviously all unchecked exceptions because we did not have a try-catch block in our code to catch those exceptions. So these are things that we can fix by more careful programming. The number list program compiles a run, but it's not very robust. So this table shows some of the unchecked exceptions that can be thrown. We covered all these. You saw these in the video, right? We entered a non-negative number, and we got the number format exception. We entered Q immediately, and we got the arithmetic exception, right? And then we also got the array index out of bounds. And this is where you can see, what the thrown exception is. If you perform integer division, you get divide by 0. If you do, too many elements, and you get an array out of bounds exception. So I'm sure understanding this earlier in the course would have helped you probably diagnose some of your problems in your code. But you have to understand, in order to understand this, you have to understand classes and inheritance. So we couldn't really put the cart before the horse. And so now we are getting more in depth as to how you actually understand and read these error messages. And as I said in the video, as part of the runtime error, the JVM prints the exception that was thrown and then prints the call stack trace. The call stack trace shows the methods that were called prior to the crash. And this part is extremely useful for helping you figure out where your error originated from. It might not actually be in the method on the top of the call stack. You might have passed a variable in and passed a variable in and so on and so forth. And so the source of your logic error might have existed prior to the actual last thing that got executed. So just keep that in mind when you're troubleshooting your code, that it might not be at this top line right here, right? It might actually be further down in the call stack.